Hello everyone, welcome to project number 10, and in this project you'll be implementing financial fraud detection system, and this project is going to be one of the most comprehensive project that you have done so far, and I have tried to make it as practical or as realistic as possible. In this project, you will actually be implementing a financial fraud detection system using Spark batch processing and stream processing. So there are two parts of this project. In the first part, you'll be preparing the data. And in second part, you'll actually find out whether the transactions are fraudulent or not, and whether you can flag certain transactions or not. So let's proceed. First, let's talk about financial fraud. So what is meant by financial fraud before implementing the fraud detection system? The purpose of fraud is someone is trying to access your financial credentials in order to gain some financial assets using your account, your financial accounts, or your financial assets. There can be different types of financial frauds. There can be card fraud, it can be credit card and debit card. There can be online payment fraud. There can be money laundering, and there can be account takeover attempts, etc. Card fraud and online payment fraud are pretty self-explanatory, but money laundering is something wherein using your account, someone else would try to send money to someone else's account, to a third-party account, or to his or her own account. Account takeover attempts are fraudulent attempts which are meant to use your account credentials for that person's benefit. Now, in this project, there are only three entities involved. There's customer entity, account entity, and transaction entity. Customer entity would contain customer details with risk profiling, and this dataset contains only 100 customers. The reason I'm not providing too many customers because I wanted to make sure that you implement this end to end and actually see the results to check whether your implementation is correct or not. So that's why we'll be using only 100 customers. Then we have the account file, and the account file contains account details held by customers, and a single customer can have multiple accounts. Finally, there are transaction files which would contain historical transaction data. Now, for this project, there are certain considerations. These are only the initial considerations. There can be other considerations or assumptions that you can make during the implementation of the project. The first consideration is that each customer will have only one device, and at the same time, each customer can have multiple accounts also. Some of the browsers are from dark web, for example, Tor, Hyphanet, Torch, I2P, Haystack. These are browsers which are very prevalent in dark web, and you should never use dark web to do any financial transactions. But fraudsters can use dark web to make a transaction on your behalf for money laundering. I'm also assuming that the current year is 2027. I'm not sure which year you are watching the video in, but as per the files that I have generated, the current year would be considered as 2027 and the previous year would be 2026. The customer and transaction lat long, or latitude and longitude, has to be converted to distance in kilometer. So you'll have to use the Haversine formula that you have implemented in the previous project. If you have not used the previous project, or if you have not completed the previous project, I would recommend that you complete that, or at least create the module for Haversine formula or to implement Haversine formula. So this is what the overview of this project is. We'll be implementing a fraud detection system. Now, as I have told you that there are three entities. There's account entity, customer entity, and transaction entity. And these are the columns for account, customer, and transaction entities. All these are actually files. There is a single account file, there is a single customer file, but there are multiple transaction files. And what you have to do is that you'll have to load them into their individual tables, like account table, customer table, and transaction table. And from there, you'll have to do some transformation and load it into transaction history table, columns of which are shown here. And there are some color coding also. By blue color, it means that you have to get the columns from customer table. The orange columns mean that the columns have to be fetched from the account table, and the black columns mean that the columns have to be fetched from the transaction table, and green columns are the one which has to be created from existing columns using some transformation or the other. Now, as you can see, this is a typical ETL. So would be having multiple files, and I'll have to load the files to a historical table. Now, the first ETL is very straightforward. You'll have to read the corresponding files. We have a single file of account data.csv. There's a single file for customer profile data.csv, but there are multiple files for transaction data. The name of the file is transaction underscore data underscore 2022 underscore 1, 2022 underscore 2, 2024 underscore 3, etc. You'll know by looking at the initials of the file, which is transaction underscore data. And what you have to do is that you'll have to use PySpark data frame to read the files and load them to their independent or individual transaction tables. There would be an account table, customer table, and transaction table, and these tables have to be created in Aurora MySQL. By the way, you'll have to use AWS for the entire project, and you might have to incur some amount of cost, not pretty high. The cost would be less. It should be done within $5 to $10. It should not be more than that. And I would recommend that you use serverless Aurora MySQL and serverless Redshift also. All right. So all these individual files have to be loaded to their individual tables: account table, customer table, and transaction table. The transaction table should contain records from all the files that I'm providing. Now, after that, you'll have to create the transaction history table in Redshift. Here also, you'll have to do some transformation using PySpark data frame APIs. You'll have to fetch the records from account table, customer table, and transaction table. Do the transformation as per the table structure that I have shown you in the previous slide, and then load the records in transaction underscore hist table. And this should be in Redshift. In ETL1, it would be doing a simple extract, transform, and load from OLTP system to OLAP system. These tables, the account table, customer table, and transaction table, are OLTP systems because you'll be using Aurora MySQL, and also the size is less and the data is pretty straightforward. But after that, you'll have to do some transformations and then load it to transaction underscore history table. So this is the first ETL, and this is the part 1 of the project.